Hi, my name is Peter, and I would like to spend a couple of minutes with you giving you a heads-up overview of the Ratio new course on moving to the Go programming language for experienced developers. Essentially what this is it's a really fast-paced 3-day instructor-led workshop / course in which we take you through the core concepts and differences of Go to other programming languages on the assumption that you are already a programmer who has experience with a modern programming language. So, when we say an experienced software developer, we mean somebody who at least knows about the concept of data types and variables and conditional flow logic, possibly object-oriented concepts, although Go is not an object-oriented language, so not so much focus there. But certainly that you have some working experience of programming languages generally. The audience, the intended audience for this course is architects and experienced developers. So you know how to program. You've worked probably in software development teams in the past. You've built software products in the past, and you are either have made a decision to move to Go or develop a new project in Go, or you are wondering if Go is the right choice and you want to learn about the language in more detail before you make a decision to select Go. So this brief presentation really has 2 points of emphasis. The first is that to give you a better understanding of why people move to Go from whatever programming language they were working with before, and then a quick heads up on the content that is included in the 3-day course. Okay, so why would you move to Go? First of all, it depends on where you're coming from. And this is what the intention of this table is to try and give you an idea that you can compare, and we do this in detail in the course, so I'm not going to do that here, but we leverage the fact that you would be familiar with concepts in at least one other language like C, C++, Java, one of the scripting languages like JavaScript or Python, C#. And then we can use those languages' core concepts and capabilities to help you to rapidly move your knowledge set into the Go space. And you know, it helps you as a potential delegate on this course to understand where Go is coming from and how it differs to the types of things that you would do on a daily basis with other programming languages. And I'm not going to go into this. This is actually stolen from the course content itself, the slide. But things like the level of the languages, at a high level language like Python, scripting languages that are a low level language like C, well, it's kind of low to medium. So you could build websites and web services in it, which is a very common type of project in Go. But you can work directly with memory allocation and pointers and bitwise operations and things like that, as you could do in C. Possibly one thing, if you look at this summary table, is to understand that how old Go is. It's actually a really, really new language. It's only been around for just over a decade, since 2012. But if you came from a C programming background, you would feel really comfortable with Go, because what Go really is a modern version of C with a memory manager built in. So a garbage collector, effectively. It's a far simpler language than C# or Java, certainly far simpler than C++. But it has the benefit of memory management, so you've got for all intents and purposes, you've got protected memory. You are less susceptible to the kinds of memory misallocation and abuse errors that occur in the C and C++ world, but you have the benefit of a modern, fully fledged programming language with things like tuples that come from the Python world and things like that. So it's not an object-oriented language. You can, as you can with pretty much any language, implement or adopt object-oriented paradigm in your thinking and in your design of your code and its implementation, but there's no concept of a class in Go. There's certainly no concept of class inheritance and class hierarchies and operator overloading and a whole bunch of other things that you would be familiar with if you had worked in C++ or C# or Java. It's more similar to C in that respect. However, it's compiled. It's a compiled language, so very much unlike Python and JavaScript, the runtime performance is extremely high. The compiler generates native code for the platform that you're running on. So you get equivalent performance to C++ or C, other than the fact that you've got the garbage collector running quote underneath unquote your code, which does add some additional overhead. But you are getting huge value, a premium value from that slight overhead, in that you don't have to worry about misallocation of memory. So it's performance impact well spent, I believe. However, not only do you get runtime performance that's far better than you get with scripting languages and generally Java and to a large degree C# as well, but you also get static code analysis from the compiler. This is not obvious, but when you're working with a scripted language like Python or JavaScript, you are very often exposing yourself via your own possible stupidity to looming bugs, things like divide by zero bugs, where you haven't always initialized a variable or something like that. The static code analysis factor of compilers either generates warnings or errors that prevent those otherwise undetected scripting bugs from occurring. So yes, I managed automatic memory management and garbage collection, very much of an inclusion in the Go world, but not in the C world, for example. So an extreme opposite there. It's also intended by design to be a very stable language in terms of how often the language will change, other than minor bug fix releases. The idea is to have a language more like C than, say, C++. For example, there are only really 3 versions of C, really, since 1970s. There's what we call C80 and C99, and then the original K and RC. Those are predominantly three versions of the C programming language since the early 1970s. I mean, that's extraordinary, 50 years with only a few changes to the language in that time. Whereas if you look at languages like C#, for example, there's a new release every year. And this is not a criticism of Microsoft's approach to C#, it's a reflection of the fact that they are adding lots of features that are not necessarily core. They are useful, but the idea with languages like Go and C, in contrast, is that you only consider adding features to the language if they're hugely useful. Probably C++ is a notable culprit, where if you've watched the evolution of C++ over the last 30 to 40 years, there are an obscene number of versions of C++ in comparison to C, and a lot of people just kind of threw in the towel with C++ because of the obfuscations and confusion that those caused. Anyway, so Go is very different in key aspects, and I'll talk about a little bit about some of those in the next slide, to probably many of the programming languages you've worked with. But as an experienced developer, you would still be familiar with the concept of declaring a variable, assigning a value to a variable, conditional execution of code, loops, and things like that. So in our course, over the 3 days, it's kind of a 20,000 foot fly-through guided tour in a sense. Obviously 3 days is a really short period of time to learn a new language, but we do leverage the fact that the assumption is you already are a programmer. So what we're doing is showing you examples, showing you how to run those examples on your own laptop, set up your own environment, but we're not going to handhold you through a typing course to in Visual Studio Code or whatever. It's not our intention. But we will show you how to set up VS Code on your laptop and install the Go compiler and to build and test and debug Go apps on your laptop, whether you're using Windows or Linux or Apple platform is irrelevant, because we support all of those environments. So we start with just focusing on the Go fundamentals, the core concepts, maybe the similarities and differences with other programming languages in terms of data types, declaration of variables and things like that. We talk about how Go functions work, and you'll see that functions can become Go routines as we'll talk about in a bit. Error handling is quite different to some languages, notably C#, where C# has structured exception handling, whereas historically languages like C had the concept of a returned value from a function call being used for error handling. Go is very much similar to C. In that sense, it doesn't implement structured exception handling. There are pros and cons to both approaches, and we try to give you an understanding of why there are pros and cons, the differences notably between C# and Go in terms of error handling, because a lot of the delegates coming into this process are coming from a Go and .NET world, so it's important to understand that. Another thing that Go is inherently designed to do from day one is rigorously and efficiently support concurrency, so multi-threaded execution of code. And so the language has built-in keywords and concepts, things like channels and the concept of Go routines, to support multi-threaded concurrency seamlessly in your code, in your applications. We also look at advanced concepts of things like how to provide thread safety when you are when you're working in a concurrent world, and all sorts of things like that, and the concept of interfaces, which are obviously useful in modern software contexts. There's a little bit of coverage on the tools that you can use either at the command line or via in our examples we will use VS Code with the VS Code extensions for Go to leverage these tools, but they are available. There's very, very comprehensive built-in unit testing capabilities within the Go environment, for example. We'll give you a brief heads up into something that's not directly related to Go, but gRPC and protobuf, which like Go came out of the Google stable and provide an alternative in inter-service communications as an alternative to HTTP and JSON, what some people would possibly call RESTful APIs. So there are possibly two different ways that you could consider implementing your microservice architectures or your service architectures in the future. And we believe it's important that you at least understand the core differences between HTTP and JSON and the new gRPC and protobuf worlds. So then we'll help you to understand with simple examples towards the end of the course how to build simple HTTP web service, quote unquote, clients and services. And we'll also look at integrating with external services. For that we use PostgreSQL, but it would work for any other database, external database service that you would be familiar with. Thank you for your time. We do appreciate it. If you need more information about this course and availability, please contact us via yourratio.co.uk.